solution. If I want to see if it's a successful solution for a differential equation or not, all I have to do is to take this solution, substitute in the main equation, and see if the left-hand side equal to the right-hand side or not, which is very, very simple. If I want to extract the particular solution from a given general solution, all I have to do is to substitute by the initial and boundary condition in the general solution, and I will find the particular solution as you can see. Perfect. Okay. لغايه دلوقتي احنا ما شفناش الطرق بتاعت الحل. Methods of solution, those are not just only the methods. There is plenty of methods for the treatment of ordinary differential equations. But those are the most famous methods that's used for solving these ODEs. Okay, here is the definition. The main methods that we will use the separation of variables technique. Then I will use the homogeneous method, which we can say it's reducible to spherical. Using this technique that you will see here, we will use a specific substitution that will force this equation, which is a homogeneous, to be a separation, to get back to be a spherical method of solution. I will also go within the next lecture to an exact first order differential equation methods, then the reducible to exact. If I got time, I will go through this function, this method of solution. The one and only linear ODEs, it's one of my favorite methods of solutions. If it is applied or applicable for a differential equation, it's going to be great. And then you will have the Bernoulli's differential equation, which simply by using a certain substitution, I will form this type of equations back to be a linear differential equations, and then we can treat them the way that we treated the linear differential equations. As we can see, we have probable 6 methods of solutions for the treatments of ordinary differential equations: the separation, the homogeneous, the exact, the reducible to that, the linear ODEs, and the Bernoulli ordinary differential equation. If we need to start with the separation of variable, لو أنا حبيت أبدأ بطريقة فصل المتغيرات أو separation of variable method، الموضوع سهل جدا جدا جدا. This method can be used if we could separate the variables of the problem in 2 opposite sides. الطريقة دي ناجحة جدا. It's very successful method. Once you succeed in getting all the x variables in one side with dx and all the y variables or the dependent variable on the other side with dy. Here's the steps of applying this method. If it is separable, if you succeed in getting x times dx equal f of y and side dy, then you will be able to use this method as we can see. Separable or separate the independent variable f of x dx in one side, and on the other side get fy dy, then integrate each side separately. كامل كل طرف فيهم لوحده خالص، يعني هنا يبقى integration with respect to x. On the other side, this is going to be an integration with respect to y. Once you succeed in this, apply the initial boundary condition if it exists to find the solution of this differential equation. انزل معايا. We have plenty of problems you can train yourself, or all of them are solved with the handout you have. So for me, it's really very sufficient to resolve them the way you see in order to be familiar with the various steps of solutions, and you will find the final solution. Let's see. If I want to treat the first equation, first of all, how to discover if it's going to be solved with the method of separation of variables. If the separation of variable, it's going to be a successful method to treat this equation or not. How to know about this? In order to know about this, it's very simple. عشان اقدر اعرف اذا كانت طريقه فصل المتغيرات separation of variable هتنفع مع الاوردينري differential equation دي، موضوع سهل قوي. كل اللي عليا ان انا اعمله ان انا اقسم الفانكشن بتاعتي ل dy و dx. الطريقة دي successful if you don't have addition or subtraction with with different variables. You have to have most of the problem, most of the differential equation, talking about first order, first degree equations, decay. I maybe skipped that when I was moving through the slides. In those methods, I will treat just only the first order, first degree equations, as you can ordinary differential equations. Okay. Now, if it is possible to get all the x variables with dx and all the y variables with dy, so this method is going to be successful. That's, you will have as many as multiplication or division in this problem for the various variables or the various parts or terms of this differential equation. They should be multiplied or divided on each other. Try to if there is addition or subtraction between the various variables that exist in this equation, probably this method is not going to be successful. This is why we will see more than one example. Okay, let's see. Okay, the first thing I will do, if I were you true, I will try to get y dash on the derivative form. That's dy by dx, which is going to equal to e to the power of x divided by 2y. Simply make a cross multiplication. If we do a cross multiplication, what's going to happen? We will have 2y times dy, which is going to equal to e to the power of x times dx. يبقى انا لو قدرت ان انا اعمل cross multiplication الاقي ال y وال dy on one side and the e and the other part will be on the other side, ex times dx. This is a successful separation. This side contains 5y times dy, and on the other side I have theta of x times dx. All I have to do is to integrate. I will integrate both sides separately. Integrate both sides. Once you integrate the left-hand side, this is the integration sign, 2 of y times dy, which is going to equal to integrate e to the power of x dx. According to the integration table, this one is going to be y to the power of 2 divided by 2, which is going to equal to e power x. Already you have the derivative of the power that exists here, which is 1. The integration of e power x is going to be e power x. Take care, in the left-hand side, it will develop a constant. The second, the right-hand side, it will develop also other constants. The constants from the left, I will move it to the right, so I will add a constant in one side. This concept is really very important. On the left-hand side, I have something that I don't know, which is the constant of integration. On the right-hand side, I also have a constant that I don't know. I'm pretty sure those are constants. This is just to obtain one-time integration for a function, single-valued function, so those are constants. Right-hand side contains a constant, which I don't know. Left-hand side, which contains another constant, which I don't know. So all I have to do is to move the constant from the left-hand side to the right-hand side. I will have C1 minus C2, which is going to be a constant, one constant, one constant. This is going to be the general solution for this differential equation. I want to find the particular solution as long as I'm giving you the initial condition. So what to do? All I have to do, I will take this condition and I will try to substitute in this equation. And I have to make condition that وأحاول أعوض. This condition states that y will equal to 4 once x equal to 0. Use those values and substitute in the general solution. It means we have 16 divided by 2. It's going to equal to e to the power of 0 plus c, which will lead to in y to the power of 2 divided by 2, 4 to the power of 2, which is going to be 16 divided by 2, so it's going to be 8. Please be careful from the algebra. E to the power of 0 is going to be 1. plus C, so we will have the value C which is equal to 7, if assuming that everything imported. Okay? Just a second, please. I made a mistake. Here I have 2y, just a second. This is why I'm telling you, you have to be careful. I was talking and I forgot that we have 2 here. So once you integrate, so it's going to be y to the power of 2 only. So once we do the substitution, it's going to be 16 to the right hand side, and the left hand side is going to be e to the power of 0 with C. This is why I'm telling you, you have to take care when you are dealing with these equations and making the right substitutions. So the general solution will be y to the power of 2 plus e to the power of x plus c. Once you start differentiating, once you start the substitution, so this is going to be 16 and 1, which will develop in the c value. It's going to be, so c will equal to 16 minus 1, which is going to be 15. Once I know the value of the constant, I will make a re-substitution in the general solution. So the particular solution will be y t, which is the particular solution, equal to e, to the power of 2 of course, will equal to e power x plus 15. This is the particular solution that you found from the general solution that obtained from this one. Okay, شباب؟ اوكي؟ زي ما انت شايف عمليه بسيطه جدا. انا قسمت الدي واي مع واي، الاي باور اكس مع دي اكس، انتجريتد بوث سايدز سيبريتلي، كملت الطرفين منفصل خالص. يبقى 2 واي لما انا كملت يبقى واي تو باور 2، اي باور اكس لما عملت كامل اتس جونا بي اي باور اكس. خلاص انا ده الحل العام general solution. All I have to do is to use the particular solution, make the substitution, I will find the values, voila, I have the particular solution. Simple. Okay. تعال نشوفها هي مكتوبة ازاي عن let's quit all of this. طبعا انا لو حبيت ان انا اكمل، شوف بقى انا عاملها لك ورقة اهي. Seems like I have a problem with my batteries. Let's see. Okay, just a sec. Okay. Just give that a second, please. Okay. We have to put this. Now, this is just a second, please. Let me see a couple of problems. Okay. This is the ODE that we were talking about. The first step is to try to separate the variables, f will be y dash dy by dx. Then rearrange terms. That we will end up having 2y dy equal e to the power of x. Integrate both sides separately. So I will integrate 2y with respect to y dx in a similar manner. Once we integrate this, you will have y squared equal e to the power of x plus c. Use the condition that exists as long as this is general solution. Y will equal 4. Once x equals 0, I will make the substitution. I will end up having c equal 15, and so you will have y squared equal e to the power of x plus 15. This is the solution for this problem. If I want to solve this equation too, it's really very simple. I will have to follow the same scheme exactly. I will try to solve it with you in order to enforce the steps or to make the steps really very simple for you. Okay. خلي بالك انا هحاول تاني ان انا احل المساله دي in a similar manner، نفس الاسلوب بالظبط، علشان تخلي بالك ان الستبس systematic. Once ان انت succeeded in solving or separating the variables. Remark خلي بالك remark is very very important. ايه الريمارك اللي انا عايزك تخلي بالك منها؟ I don't have addition or subtraction. Once I have addition or subtraction, I start to be a little bit worried if it's gonna be successful or not. لو انا عندي addition or subtraction جمع وطرح هبدا اتخوف شويه ان الطريقه دي ينفع انها تمشي. بس انا ما عنديش سبتراكشن، فاعمل ايه؟ فبالتالي انا سهل عليا قوي ان انا اعمل السيبريشن بتاعي. ليتس تراي، ليتس جيف ات ا تراي. Just a second. I will try to solve it with you. Okay. Once more, I will have to replace y dash by dy by dx. So I will have x times dy by dx, which is going to equal to 3y. Try to get all the y variables in one side with dy and all the dx variables to the other side. If we make also a cross multiplication, we will have x times dy, which is going to equal to 3y times dx, a cross multiplication. Then I will try to get the dy by y in one side and the x variables with dx on the other side. I believe this is going to be done very easily by getting dy by 3y, which is going to equal to dx over x. So what we can say that in dy divided by y, which is not equal to 3, okay, dy over y, which is not equal to 3 times dx divided by the other variable, which is x. We have tried to rearrange our terms, getting dy over y, and from the right hand side, once you are leaving to the left hand side, take dx and the 3 divided by x. So if we make a cross multiplication again, it will be the same, so we are in a better position. Now we succeeded in separating those variables. احنا نجحنا ان احنا نفصل الفاريبلز دي زي ما حضراتكم شايفين. كل اللي عليا اعمله دلوقتي ان انا I will integrate both sides. Once ان انا وصلت للستيب ده على طول هروح اقول له انا will make integration for both sides. I will integrate both sides. يعني اذا ده معناه ان انا I will integrate dy by y, which is going to equal to integration of 3 dx by x. That's the بعمل integration ده ايه اللي هيحصل؟ هيبقى عندي right hand side, left hand side is going to be len y, which is going to equal to 3 times len x. Supposed to add the constant of integration. Okay, انا make successful integration to both sides. دلوقتي انا عندي len y equal 3 len x بس. Once you have len on the left hand side and len to the other hand side, I can use some of the very famous logarithmic function substitutions and relations. See, if you remember that we all already know. Wait, let me put it this way. It's going to be much nicer for you, and it will be very nice. Let me recall these properties. If I have a times len b, it's going to equal to len b to the power of a. This is one of the very famous properties of the logarithmic function. Also, we will have, you know already that len a times len b is going to equal to len a times b. Also, you already know if you have len a divided by len b, it's going to equal to len of a by b. Okay? So if we have len a plus, so if I have len a plus len b, it's going to equal to len a times b. If I have len a minus len b, it's going to equal to len a divided by b. Using these three properties, we can deal successfully with the logarithmic function. Also, I want to state that len 1 equal to 0, okay, and len e to the power of x equal to 0. Also, if we have x, we can put it on the form of e to simplify a certain arithmetic function. Depending on these facts, I can assume that C, which I don't know the value of this constant, will equal to len times any other constant, say B. It isn't C, another will not say B. And I will get benefited from this substitution that len y is going to equal to len x to the power of 3. I've used this one. Then I will have replacing C by len B. This will force the right hand side to be rewritten on the form. Len y will equal to len x to the power of b times b. I've used this property. يبقى انا استخدمت خاصيتين، الخاصيه بتاعت الارثماتيك فانكشن. الخاصيه بتاعت الباور ان 3 لين اكس يساوي لين اكس تو ذا باور اوف بي، وان انا عملت ريبليسمنت شلت السي وحطيت مكان لين بي، واستخدمت البروبرتي ان لين اكس تو ذا باور اوف سي بلس لين بي والايكوال تو لين اكس بار 3 تايمز بي. تيك انتي لين فور بوث سايدز، اقدر دلوقتي احذف اللين فور بوث سايدز. ريموف لين from both sides, take anti-len. That's in the y will equal to b times x to the power of 3. This is the general solution for this differential equation. This solution of differential equation solution. If I want to have a particular solution also, I can use this condition. بكل بساطة أنا دلوقتي عارف إن الباوندري condition اللي أنا بقوله in y will equal 5, once in x equal 2, try to make the substitution. That's in the 5 will equal to b times 2 to the power of 3. That leads to in b will equal to 5 divided by 8. So once more, I will rewrite the particular solution. In such a case, the particular solution will be y equal to 5 divided by 8 times x to the power. أنا كده جبت الجنرال سوليوشن وجبت البارتيكولار سوليوشن. يبقى دي الميثود اوف سيبريشن اوف فاريبلز، وهي من الميثودز السكسسفول جدا as I mentioned. الديتيلز بتاع this solution you will find it in the handout already uploaded on Canvas at the time. اوكي؟ تعالوا نشوف ده written ازاي في الهاند اوت اللي هيبقى موجود معاك. اهو once more دي الفانكشن بتاعتي انا فكيته، عملت السيبريشن اوف فاريبلز. I will integrate both sides, so this is going to be in y to be ln x plus c. I will replace c by ln a. I will have ln y equal 3 ln x to the power of 3 plus ln a, which will force the right hand side to be ln y equal ln a times x to the power of 3. That's y equal ax power 3. Use the particular solution to replace every x by 2 and every y by 5. Already done. أنا بالفعل عملت ده. ليكم معايا ثانية to check something. Okay, perfect. يبقى إذا أنا على طول عملت ده زي ما أنا قلت لكم يا باشمهندسين. الستيب اللي بعديها أنا I made the substitution. Already I know the value of a. يبقى إذا جبت the particular solution. This is the general solution and that's the particular solution of this ODE. This is also another problem that you can use in separation of variables. لاحظ ان المسألة دي although you have addition in both sides, which makes you a little worried that the separation of variables may work, but remark that once you try, think first, look at it, take a deeper look. If you can see, if we multiply y in 1 and multiply y times x, so this can be separable as the y on the left hand side will go with the y on the right hand side and the problem will be separable. See? اهو انا will try to do it once more. اهو انا على طول اعمل دي الفانكشن بتاعتي multiply y times x, y times x. The second part, see y from the left hand side will go the y from the right hand side. So this is this is gonna be, at this time, this is considerable. Here, it's gonna be separated simply as all the differential equation contains multiplication and division. So we can try to rearrange our terms. I will make a cross multiplication, then I will divide by y. لو انا عملت كده يبقى عندي dy by y which equal to x times e to the power of x squared. The integration here will be very simple. If I want to make the integration now, it's going to be very simple. All I have to do the integration for this part is going to be my. For this part, this is the integration of x times e to the power of x squared dx. Please do remember that if I want to integrate f dash x times e to the power of f of x dx, the integration, once this is the condition that the power already its derivative exists in front of the exponential function. This is according to the differentiation table that I've given you previously. So the solution will be e to the power of f of x plus c. This is the integration. Okay, perfect. But I have a problem that this power is x to the power of 2. Its derivative is 2x. See? The derivative of x squared is 2x. I don't have this here. All I have to do is to multiply by 2 and then divide by half. Now the condition is correct. X to the power of 2, the derivative is 2x. So simply I can say that then y is going to equal to half times e to the power of x squared plus the constant of integration. Once more, I can use the condition. This is the general solution. This is the general solution. Okay, so this is the general solution. I can use the particular condition or the initial condition, find the particular solution. All I have to do is to make these substitutions, and y will equal to 1. Once in the x equal to 0, if we make the substitution, so it's going to be then 1. You can really say we half e to the power of 0 plus c. That's in c will equal to negative half. Then the particular solution that you are seeking is then y. It's going to be equal to half e to the power of x squared, and I will replace c by negative 1 over 2. I got the particular solution. So this is the general solution. This is the particular solution for this one. Okay يا شباب؟ الأمور تمام؟ أي مشاكل whatsoever؟ Okay, perfect. Thank you. Once more زي ما أنا قلت لك أنا عملت الانتجريشن in a similar manner x e to the power of x squared, so the integration will be half e power of x squared. Use the condition. Once you use the condition, you will find the value of c equal to negative half. So the particular solution will be n y equal half e x power 2 negative half. If you want to go further in manipulation and you want to get the y on one side, use the probabilities that I supported before. That's n y equal e to the power of half x squared minus half. So it's going to be this one. Okay, this is also one of the very famous problems. You will find its solution on Canvas, the handout on Canvas. This is very simple. Let me show it to you, and I will stop at this point and go to the next method. From the first look, this problem, it's not going to be simple. As you can see, we have addition, subtraction, division, multiplication. It's very hard to separate it, but wait. No, just wait. Let me look at this. Okay, if I took x from these two terms, I will have x minus y. If I take negative sign as a common from these third and fourth terms, I also will have x minus y. And if I take y from R, it's gonna work. Let's go for it. I will say that dy by dx will equal to, I will take a common from this, the first term and second term. I will end up having x minus y. then I will take negative as a common, so it's going to be negative x minus y. Also from the denominator, let's take y as a common, so I will have x minus y. If you remark, okay, so it's really going to be very easy to do it. All I have to do is to have dy by dx, which is going to equal to, I will take x minus y. This is x minus y as a common. From the denominator, I will have x minus 1, and from the denominator, I have also x minus 1 times y. I can remove these two parts together, so you will end up having dy by dx, which is going to equal to x minus 1 divided by y. Let's make a cross multiplication. That's y times dy will equal to x minus y times dx. Here we go. Integrate both sides. I'll integration for both sides. So I will end up having y squared over 2, which is going to equal to x minus 1 to the power of 2 divided by 2. Plus a constant. This is the general solution. If I have a condition, initial or boundary, I can substitute and find the values. A complete and detailed solution for this problem, you will find it on Canvas, so there is no problem. Let's take a look how we succeeded in taking a series of common factors that will cancel that will be cancelled together, and the remaining will be separable. Okay, perfect. You have the solution, as I told you before, and the integration. The method that I want to speak with you now is the homogeneous or reducible to separable. There is we can use some of the simplifications or simple substitution that will force this unseparable equations to be separable. How to check it's going to work? It's really very simple. All you have to do is to take the function y dash, which is a function in x or y, replace x by lambda x, replace y by lambda y, and you will find out in these two values, it will once more make f of x or y will equal exactly the same the function of f lambda x or lambda y, and the constant you added will be removed, so you will be negotiating. تعالوا نبص عليها كده. انا كل العمليه ببساطه لما جيت عندي المساله دي ينفع انها تبقى هوموجينيوس لو انا عملت ريبليسمنت الاكس بلاندا اكس والواي بلاندا واي، اقدر اخد هتلاقي ان التيرم اللي انا حطيته ده كان يقدر ان هو تو بي ريموفد سمبلي، وهيبقى اف اوف اكس وواي يساوي الاذر سايد، وبالتالي المساله بتاعتك ينفع ان انا تعالى بص كده على السبستيتيوشنز. Steps of solution. Let's طبعا انا ما بستخدمش we don't use the homogeneous or separable to reducible unless we didn't succeed in separating the variables. So I will have to do the check, replace every x y by lambda x or lambda y. You will find them, they will get back again to be similar to each other. Use the suitable substitution in order to solve this equation. One of the famous substitutions is to allow y over x equal t over u, and try to resubstitute the problem. We'll get once more back to this level. So use the appropriate substitution of the problem that will change the problem to be separable once more. Separate the variables, integrate separately each side, add the arbitrary constant, and then finally use the initial condition to find a particular solution. And also you can make a resubstitution to regain the main variables over. It's going to be better to see it on a problem. Those problems are all solved with you, so you should be in a good place. All of them are solved on the handout of this. Let me try this problem. And solve it together and check how to go through this method. بكل بساطة I'm sorry for the sound in the background. It seems like the maintenance guys are trying to fix something. So I'm really very sorry for the sound that you will hear in the background. But I want you to try to listen to me. Just focus with me and everything will be fine. First of all, this function is not going to be separable. See, I'm not going to be succeeding in getting the y variables with respect to y and the x variables with respect to dx. It's not going to be easy for me to do this. So all I have to do is to try to check if it's going to work using the homogeneous solution. See what I will have to do. All I will have to do is to replace y by lambda x, and I will replace every x by lambda x. So this will lead to, in y dash will equal to set, but in y it's going to be lambda times y. I will replace x by lambda x, and then I will have lambda y divided by lambda x. As you can see, lambda will be removed from all of them. So once more, it will get back to be sec y over x plus y over x, which is going to equal to exactly the same as y dash. It's going to be like the original function once more. So this is what we do. أنا على طول أول ما لاحظت رحت جاي شايل كل واي حطيت مكانها لامدا واي، كل واي شلتها وحطيت مكانها لامدا تايمز واي، وكل اكس شلتها حطيت مكانها لامدا اكس. عملت السبستيتيوشنز، شلت الواي حطيت لامدا واي، شلت اكس حطيت لامدا اكس، سيم واي رايت، كنسلت اللمبات مع بعضها، بقى عندي سيم واي اوفر اكس ماينس واي اوفر اكس، والكلام ده بقى بيساوي واي داش. اقدر احل المساله بتاعتي دلوقتي مفيش اي مشاكل whatsoever شرط. طيب تعالوا نيوز the substitution. Substitution اللي انا هستخدمه هنا I will let, okay, I will let y over x equal u. Once انك عملت السبستيتيوشن ده، يعني ده معناه ان y will equal u times x، وده معناه ان y dash